In this video, I discuss how I went about integrating, essentially mostly electrical integration, of the original Corvette minus the engine and transmission and a few other systems with the new electrical vehicle components. This is the last of the videos for my Corvette project. You would have seen some earlier videos, possibly online through YouTube, showing my introduction, the motor, the control system, the battery, which consisted of two separate videos, all the ancillary systems, and now lastly my vehicle integration approach. I will explain how I went about vehicle integration in 4 steps. Number 1, vehicle startup and run mode. Number 2, my 12 volt EV sources. There's the always on, and then there's also the ignition mode. Number 3, a shift switch and indicator lights that you had a highlight of in earlier videos, and also how I hooked up my reverse lights. And lastly, number 4, how I powered up the DC to DC converter, the coolant pump, and the radiator fan. And the reason I'm focusing on this separately from the overall control system is the approach for these items differs between charge mode and run mode. So starting with vehicle startup / run. The Corvette was one of the earliest vehicles that had the push to start feature, and my objective with this car was to make this transparent for the operator. So when you get in the vehicle, all you have to do is push the start button and the vehicle will fire up immediately, including the electrical vehicle portion of it, without any error messages on the driver information display or check engine light and so on. So I've managed to do that, and I do this by having the car truly start up. It's almost like when you go to start a vehicle and the engine doesn't start but everything fires up. So that's the way this system is going to be working. It's in run mode, but the engine just isn't running. But even though it's not running, the ancillary systems such as ABS brakes and vehicle ride control, which are 2 great features with the Corvette, will continue to operate. So my technique to do this was really to completely sever all connections from the vehicle to the engine control module, which was about 150 wires. Those cable bundles, there were 2 of them. There are 2 of them that were about 1 inch diameter. And so I did that and then started building it back up again, making the connections in an incremental fashion to, of course, minimize the number of connections that I'm using and still make the system work the way I want it to. I also used a Tech 2 clone type device to continually monitor the status of the error messages, the DTCs if you will, as a result of the work that I was doing. So this is a simplified picture of the ECM and the connections that were necessary for me to get to where I was satisfied with the system function. Of course, the first step was to hook up all the power, ignition, and ground wires to the ECM and the GM LAN. In the Corvette, the beginning of the GM LAN network is the body computer, and it ends with the ECM. So those were the first 2 things that I hooked up. Then began my process, and of course I knew that for the Corvette to start up immediately, I needed to have the clutch depressed So I put the clutch pedal position sensor, which I retained in the passenger compartment, and put that in the full depressed position so that the BCM and ECM would know that the clutch pedal was depressed. So once doing that and pressing the start button, I had a myriad of error messages that would pop up and go through the DIC, the Driver Information Center. So number one was I needed to do something about the accelerator pedal, which I no longer had hooked up because I was using it for the electrical vehicle portion of the program, and the throttle position sensor, and both of those work together in unison. You press one and then the throttle position sensor picks up the movement in the throttle valve. So the next step was to emulate those two items. I emulated the accelerator pedal position sensor with a set of resistors as you see in this diagram. I knew what the voltage values needed to be for both the B input and the E input from the sensor to the ECM, and I just replicated that with resistor values to create those numbers, and it seems to be working fine doing that. I tried to do the same thing with the throttle position sensor. Again, I knew what the voltage values needed to be, assuming the throttle body was in the idle position, but it would not work. The sequence at startup is the ECM causes the actuator of the throttle to move slightly, and I guess it's probably a methodology to zero out the sensor, but I was not able to replicate that, and so I used the existing throttle body and sensor and mounted it in the side of the car by the engine control module, and that seems to work fine when it's paired up with the accelerator pedal sensor that I did emulate. The next issue was the fuel system. Of course, the gas tanks are gone, and the ECM was looking for input on the fuel levels in the two settle tanks, and of course the emission system is gone and the fuel pump's gone and so on. So the only system issue that was critical for startup were the fuel level sensors, and so I had to emulate those as well. The fuel level sensors were easy to replicate as well. I took the measurements, resistor values for the two settle tanks, and replicated those resistance values as you see in this chart, and as a result of that, at startup the instrument cluster reflects full fuel in the vehicle, and I no longer get the driver information center to reflect low fuel with the vehicle. Now keep in mind the MIL, or the check engine light if you will, is no longer connected to the ECM, as I showed earlier in my coolant flow diagram, and how I use the check engine light to tell me if the coolant is no longer flowing. So there's a number of errors that are being generated by the ECM that are not being shown on the instrument cluster because of that light is not hooked up. What I'm really concerned about is just eliminating any error messages that come across the DIC. So at this point I was able to get instant vehicle startup by pressing the start button for both the vehicle and the electrical vehicle portion of the car. I still wanted to have vehicle speed on the instrument cluster and also in my heads-up display. And so I was able to do that by making a few connections as I show here. Connecting the vehicle speed was actually very straightforward on the Corvette. The vehicle speed sensor is actually located on the rear differential compared to many cars where it's mounted on the transmission. So I had the vehicle signal easily available to connect to the ECM, and then I made a connection from the ECM to the instrument panel to give me the speed signal. This still could easily have been done if I had a speed signal that I could take off of the electric motor that I installed, maybe perhaps pick it up the encoder signal and then translating that through a microcomputer and using that as a signal to the instrument panel. But the way it worked out was very easy. So with these connections to the ECM, I was able to get the transparency that I was looking for. So at start up, by pressing the engine start button, not only does the vehicle fire up, but also all the electrical elements associated with the EV portion of the car fire up as well. The only issue I still have remaining is because the engine is not running, but I'm using, as far as the body computer is concerned, I'm using current out of the battery, that after 20 minutes I get the battery saver mode started and it wants to shut down like seat heaters and other systems. Now for the most part I don't really see that as an issue given that it's a summer vehicle, but I would like it to be fully transparent. So after 20 minutes I have to reset the DIC to get rid of that error message. I did try to go quite a bit further and have the engine start up, and that creates a whole load of other issues that are very difficult for me to emulate, and so I've elected to stay where I am. If anybody who's listening to this video knows of a way to disable the battery saver mode, I'd like to know how to do that. But as far as I can tell right now, the body computer is looking for information that the engine is actually running, and because it's not running, it knows that it's going to need to shut down some systems to save battery, even though I'm charging the battery, maintaining the charge level with my DC to DC converter. Next, I'd like to talk about the EV 12 volt sources, and there's two types. There's one 12 volt source that requires it to be always on, and that's so that when you have the vehicle off and need to charge the vehicle needs to recognize the J1772 charger and begin the charging process even though the vehicle is not running. And the second is the ignition on 12 volt source, which as soon as you start up the vehicle, it will provide 12 volts to run the various EV specific controls of the electric vehicle, such as the controller itself, the ignitions or the gear selections, gear selector, toggle switch, and so on. So my next slide here explains how I do that. So this chart shows how I develop the two 12 volt sources for the EV. On the left is the always on, and I was able to actually pick this up directly off what was the cigar lighter, as they call it, in the center console, and that's convenient because that's where I actually pick up a lot of my wiring and take it to the back of the vehicle. And what I did was I I converted that wire to what I call a USB port, and I changed the resistance or the fuse value to be more in line with what I was controlling with that. And I put a toggle switch in the where the fuel door is, and that's where I actually have my J1772 connector for charging the vehicle. So it looks nice. It's nice and clean. You pop open the fuel door like you normally would to fuel the vehicle, but instead it's the port for charging the vehicle. And I have a toggle switch there that when you turn on the toggle switch, it actually provides power to the Orion BMS and wakes up the BMS so that it does recognize when a charger is connected to the vehicle. If you did not have that toggle switch, it would not start up and start charging the vehicle. When charging is complete on the vehicle, then you disconnect the J1772 connector. Then I just turn off that toggle switch. Now, in reality, I think the vehicle doesn't pull a lot of current if you had this connected directly, but given that my vehicle can go a number of weeks without being used, I wanted to make sure there was no battery drain. So just using that toggle switch would work fine for me. The second is ignition source, and this is actually more difficult than you would initially believe. The Corvette, like a lot of electronics in modern vehicles, actually uses what they call an open drain for turning on and off various items in the car, and therefore you do not really have easily access to the 12-volt source. However, on the Corvette, there's I believe two items. One that was readily available to me was when you turn on the ignition and the car starts up, there is a 12-volt source that turns on the wiper system, and I was able to pick up that 12-volt signal, and I drive a separate relay what turns on with ignition, and then that 12 volts is what supplies power to my control system. So number three, I'd like to talk about my shift switch and indicator lights, which also allows me to drive the reverse lights. This is a schematic of how I wired up the shift switch and reverse lights. So I use a double pole, double throw toggle with a long lever. I think a lot of builders take a lot of creativity here and create different shift mechanisms. I prefer to keep it more modern looking with a regular toggle with a long lever. And next to the toggle are three indicator lights, green for forward, N for neutral with the yellow indicator, and red for reverse. And that's similar to my other EV projects that you may have seen on my YouTube channel. So when the toggle is in the forward position, of course the forward green light comes on. It provides 12 volts to the controller, and also turns on one of the relays that's in line with the neutral light and prevents the neutral light from working. If it's in neutral, and I like a neutral position that keeps power away from the controller, and when it is in neutral, the yellow light comes on, and it's a good position because if somebody gets into the vehicle, let's say you swap drivers, you have the brake on, you can put it in neutral to keep any inadvertent accelerations from being attempted when somebody gets in and touches the accelerator pedal. So when the toggle switch goes into the reverse position, of course the red light for reverse comes on, and reverse power is supplied to the controller. it turns off the or turns on the relay for the neutral switch, and therefore again the neutral light would not come on. So the neutral light only comes on when there's neither power to the forward or reverse directions. In the reverse direction, it also provides power to the reverse backup lights. Originally they were incandescent lights and drew quite a bit of current. I don't have the data in front of me, but it would be prohibitive to drive those lights with this low current circuit. But I did switch those to LED, and of course the current draw is much less, and there's no issue with that. The last thing I want to talk about, number 4, is how I power the DC to DC converter, the coolant pump, and the radiator fan. And the reason I'm going to briefly talk about this, I did wire up a relay system that allowed the functionality to be different between charge mode and normal run mode or ignition mode. So this schematic shows how I wired up the power for the DC to DC converter, the electric coolant pump, and the radiator fan. So when you put the vehicle into charge mode, the charger safety is an open drain. It goes to ground and turns on the relay, which powers the pulse width modulated driver and of course the radiator fan. And I have this set so it goes at a pretty low speed. It doesn't draw much current, but when it's in charge mode, I want the radiator fan to be working. The car is not moving, so I want air to move across the radiator. I did try this without having the fan on, and the temperature gradually raises because you are charging the vehicle, and of course current is going through the charger, but also the DC to DC converter is also running, and so the coolant does increase in temperature. It raised about 20 degrees Fahrenheit from ambient, which is still fine, but I wanted to keep that temperature always at ambient, which is let's call it in the mid 70s to mid 80s degrees in the climate where I live. And it works fine, and I can control with a knob the pulse width modulations, which drives the speed of the fan. And but right now I have it set maybe at about 10% of the potential speed, and it seems to work just right. And then of course when you're done charging, the fan will kick off, so it's also a good indicator when the charging is done. I need the coolant pump to always run as well, and you'll see that I've set that up so that no matter if the relay's on or off, that coolant pump is always running, and the DC to DC converter is always running. And so either in charge mode or run mode, those two items are always on. So this completes my initial review of how I actually made the Electric Corvette. If anybody has any questions, of course, feel free to send me a message and I'll try to answer it. The car is actually in storage for the winter months, and anxious to get it back out this spring and get some more time into it. But I'm very happy with how it's turned out, and like I said, as I've reviewed the vehicle, the only remaining open issue that I'd like to work on is to get rid of the error message after 20 minutes that shows the vehicle into battery saver mode. And there may be a simple solution. I believe one idea is to actually literally get in and change the program itself. which I do not have the mechanisms to do that, but maybe I can find somebody that can do that to keep all the functionality except for changing that particular item. And it's not a big deal because it really doesn't impact anything I do other than resetting the DIC after 20 minutes of driving. So again, thank you very much, and I hope you've enjoyed my videos. The intent was purely to let people see how I've been able to do this with a newer vehicle. You see a lot of conversions with older vehicles that do not have the CAN bus and so on, but it seems to be working fine. I have what I call a nice reasonable compromise between not having the vehicle run and full running of the vehicle.